Okay guys, today we're doing lesson 1.3, solving simple equations. The first example we're going to look at is solving equations by addition or subtraction. So what we do is we use inverse operations, which means the opposite of addition would be subtraction. So they do undo each other. That's the word I was trying to say. Just like the opposite of multiplying is dividing. So whatever's happening in the problem, in order to solve for the variable, you do the opposite in order to get rid of it. So this first example right here, number A, or letter A, x minus 3 equals negative 5. So what we would do right here, since we are solving for x, we want to get it by itself with an equal sign. So we have this minus 3 right here. So we would do the exact opposite on this one where they worked it out, and we would add 3 to both sides of the equal sign because you have to keep it balanced, so you have to do the same thing on both sides. So then when you bring everything down, you're left with x. Negative 3 plus 3 is 0, an equal sign, and then we have negative 5 plus 3, which is negative 2. So our solution is x equals negative 2. Just like if you come over here and you plug it back in, negative 2 minus 3 more is negative 5. The next example, letter B, says 0.9 equals y plus 2.8. So it's down here. So now if you notice, the y, our variable, is on the other side of the equal sign. That doesn't matter. We just still work it out the same way. We're going to keep it on that side, but we want it by itself. So I have to get rid of this plus 2.8. So since it's being added, we would do the exact opposite and subtract 2.8 from both sides of the equal sign. So when we bring that down, we have 0.9 minus 2.8, and that gives me negative 1.9. I have an equal sign, a y, and these canceled. So our solution is y equals negative 1.9. If you just leave it this way, that is still correct. So they plug it back in to double check. So we have 0.9 equals, we plug in negative 1.9 plus 2.8. When you plug that in your calculator, it does equal 0.9. So what I would like you to do now is problems number 1 and 2 at the bottom says monitoring progress. Try those and then we'll go over them together. You'll have to pause the video. So it's 1 says n plus 3 equals negative 7, and 2 says g minus 1/3 equals negative 2/3.
Okay, so on problem number 1, n plus 3 equals negative 7. We're solving for n. Here's n and the equal sign, so we have to get rid of this 3. If you remember, you do the opposite of whatever's happening. So we're going to subtract 3 from both sides of the equation to keep it equal, because negative 3 equals negative 3. Then you're just bringing everything else down. 3 minus 3 is 0, equal sign. Now negative 7 minus 3 more is negative 10. So n equals negative 10 is your first solution. On the next one, here's g and our equal signs. We have to get rid of this 1/3. It's being subtracted. So I add it to both sides of the equal sign. Do the exact opposite. Negative 1/3 plus 1/3. When they are inverses of each other, opposite signs with the same number, it always cancels out and equals 0. So I have g equals negative 2/3 plus 1/3. So you have negative 2 plus 1, which is negative 1. You keep your same denominator. So g equals negative 1/3. So if we look at example 2.
Okay, on to example 2. Now we're going to look at solving equations by multiplication or division. These still work the same way as far as you do the opposite of whatever's happening in the problem in order to solve for a variable. So for example, if we look at problem A, we have negative n over 5 equals negative 3. So this right here means n divided by 5. So this negative goes with the whole fraction, or you can keep it with the top or the bottom. Since we are trying to solve for n, we don't want it left as negative n. So I'm going to say that negative goes with the bottom. So if I reread this, I have n divided by negative 5 equals negative 3. Since it's being divided, we are going to do the opposite and multiply. So if we look right here where they've worked it out step by step, we take what's on the bottom and we multiply it on both sides of the equal sign. Well, when we do that, just like we've talked about here, you can put negative 5 over 1. Let me do that. We can put negative 5 over 1. When you have two fractions and the same thing is on top and bottom of opposite fractions, they cancel, which is what we wanted. We want to be left with just that n. So now if I come back, on this side of the equal sign, we have -5 times -3. A negative times a negative makes a positive, and 5 times 3 is 15. So our solution is n equals 15. So if you come over here and check it, we plug 15 on top. So 15 divided by -5 is -3. So that's our solution. Now if we look at problem B, that looks funny, but that's pi. We have pi x, so pi times x equals -2 pi. So again, we're solving for x on this, so I've got to get rid of that pi. It's being multiplied, so we would do the opposite on this problem and divide. Anytime you do something on one side of the equal sign, you have to do it on the other. So we divide both sides by pi. When we do that, it cancels out, because pi divided by pi just equals 1. So when I say cancel out, I mean it equals 1, because if it equaled 0, 0 times x would cancel our 0. So it has to equal 1, because 1 times x is just x. So on this side, we have -2 pi divided by pi. Well, we just said pi divided by pi equals 1. -2 times 1 is just -2. So it cancels, basically. So our solution is x equals -2. So if you come back over here and plug it in, if we plug -2 in for x, I have -2 pi, and that equals -2 pi. Okay, this last example, they use decimals. So problem C, we have 1.3z equals 5.2. So 1.3 times z, so to get rid of that 1.3, we're going to divide. So we divide both sides by 1.3. So 1.3 divided by 1.3 leaves me with z. And 5.2 divided by 1.3 comes out to actually exactly 4. So z equals 4 is your solution. So what I want you to do now is at the bottom here, you're going to work out problems 4 and 5, only 4 and 5 in your composition book or your notes, wherever you're copying that down. Pause the video while you work them out, and then when you press play, you'll be able to see me working them out with you. So go ahead and start those problems now.
All right, so on problem number 4, we have y over 3 equals -6. So we are solving for y. We have y divided by 3. So to get rid of this 3, because we want y by itself with the equal sign, we have to do the opposite. The opposite of dividing is multiplying. So I'm going to multiply both sides of the equal sign times 3. This cancels, and I'm just left with y equals, then I have -6 times 3, which is -18. Y equals -18 is my solution. On this one, I have 9 pi equals pi x. So I'm solving for x. It's on the opposite side. That doesn't matter. We still just solve for it. So it's being multiplied, so I have to divide both sides by pi. This problem looks weird, but it's okay. It's actually pretty simple, because 9 pi over pi, your pi's cancel, and you're just left with 9. So you can write it this way, or if you want to flip it around, either one of those are correct. X equals 9.